Hello all, welcome to our lesson on linear inequalities. Here today we're going to first start by talking about what a linear inequality is, how to represent the solution, and then what it looks like on a graph. So let's start off with what it is. So a linear inequality is an inequality relationship between typically two variables. The solution to a linear inequality, unlike a linear equation though, is going to be a region or set of ordered pairs. So there are going to be multiple answers to each of these problems, and so we're going to talk about how we can represent that nicely. So let's see what we mean with an example here. How can there be more than one correct answer? So if we look at the linear inequality, 2x minus 3y is less than 15, let's consider the following 4 points to see if they satisfy or make this a true or false statement. So for the point 2, 5, we can substitute those points in. So 2, plug in 2, minus 3 times 5. Let's see if that is less than 15. Well, that would be 4 minus 15 less than 15, which would be negative 11 less than 15. Is that true or false? That is true. So 215 is part of the solution to this inequality. Well, let's check the point negative 1, negative 7. 2 times negative 1 minus 3 times negative 7, is that less than 15? Well, that's negative 2, and then we're going to, since we're having negative 3 to negative 7, then we're really going to add 21 and see if that's less than 15. Well, negative 2 and 21 is 19. Is 19 less than 15? No, that is not true. So that is false. So this is not an ordered pair that is a solution to this inequality. Let's check 3, negative 4. 2 times 3 minus 3 times negative 4. Is that less than 15? So that's 6 plus 12. Is that less than 15? Well, that's 18. 18 is not less than 15. So once again, that is false. What about 0, 0? Well, that's nice. 2 times 0 minus 3 times 0. We can check that quickly. We're going to use this often, actually. We get 0 is less than 15. That was nice and quick and easy. And yes, in this case, 0 is less than 15, so 0, 0 is another solution. So we found two ordered pairs, 2, 5, and 0, 0, that are both solutions to this inequality. But it's not every number is not every ordered pair isn't a solution. These ones are not. So we're really going to talk about where to find the correct answers, the values that are solutions, where the other ones aren't. So from your worksheet, I'm going to change up the steps a little bit, and I'm not going to really go ahead and call them steps because I think there's a couple different ways we could approach these. One thing that we're going to talk about is when we're graphing these on a coordinate plane, there's going to be an important distinction between the symbols less than, greater than, and the symbols less than or equal to, greater than or equal to. So we've always said that less than, greater than, that means it can't, be equal to it. So if we said like x is less than 5, 5 is not an answer. But if we said x is less than or equal to 5, well, then 5 is an answer to that inequality. So just like when we had on number lines when we were graphing them, the less than 5 would be an open circle, but a less than or equal to 5 would be a closed-in circle. We're going to have similar different symbols for these situations on our graph. So to kind of represent that when it's just a less than or greater than symbol, the point on that line is not part of the solution. We're going to use a dashed line. And when we have the less than or equal to or greater than or equal to, we're going to use a solid line. Let's look at an example and we'll see how that works. Okay, so here we have the inequality 2x minus 3y is less than 15. It's in standard form right now, so there's a couple ways we could go about graphing it. We could go about graphing it by finding the x and y intercept. But since I'm looking at the coefficient of the x here, 2 does not go into 15 nicely. Instead of doing by the intercepts, let's go ahead and write this in slope-intercept form. We'll subtract 2x from both sides. that'll make it a little bit easier for us to graph this line. So negative 3y is less than negative 2x plus 15. Okay, so we need to divide by negative 3 on both sides. We'll divide all the terms. But if you've forgotten, since we haven't done inequalities in a while, when we divide by a negative, we still have to follow those same rules that we are going to flip the direction of the inequality. So it was a less than, now it's a greater than symbol. So this is going to be 2/3 x and minus 5. Okay, so we see this part. We've graphed equations like this in the past, so graphing this inequality is going to start off very similarly. We're going to start off by going to the y-intercept at negative 5, and we're going to count by the rise and run up to over 3, and we find another point. That's the only other point we can find on this space that we've been provided here. Okay, so if we think about this point, these points here, so this is the point, it's over 3, down 3, so that's the point 3, negative 3. So let's think about that point. Is 3, negative 3 an answer, a solution to this inequality? Well, if I plug in negative 3 for y, greater than 2/3 times 3 minus 5. Okay, 2/3 of 3 is 2, so is negative 3 greater than 2 minus 5? We get the fact that negative 3, is it greater than negative 3? It's not greater than. If there was an equal to bar, it would be okay, but it's not, so that's not true. So we would say this is false. So our graph is going to represent all of the possible answers, all the answers that should count. So as we kind of looked with our symbols, that's kind of why we're going to graph a line through these that's going to be dashed. You should use a ruler. I'll do my best to make it straight here. We'll make a dashed line. We'll put arrows on both sides. So that's our line for our equation. Now, as we said, there are a whole bunch of correct answers that work for this. So where can we find the correct answers? Well, a nice place to do is an important thing to recognize is that on one half of the line will be all of the true values. On the other half of the line will be all of the false values, all of the incorrect values. So let's take a test point, a point that's not on the line. If we can, we should always choose 0, 0. That's a good test point. So let's test 0, 0. So I put 0, 0 in. I get 2 times 0 minus 3 times 0 is less than 15. Actually, we did this up above. So 0 is less than 15. Is that true? Is 0 less than 15? Absolutely. So because it's true, we get a true point on this half of the line. Well, all of our true points are going to be on this half of the line. So we're going to go ahead and you can either shade lightly with your pencil. You don't have to obliterate everything and make it so dark that we can't see anything. Or you can grab a highlighter and just kind of shade in. This half is going to be the half with all the true points. So in fact, any point that you would have picked, if you would have picked this point, which is negative 3, 3, or this point, which is negative 1, 4, or this point here, which is negative 4, negative 2, all of these would be true. And if we picked any point down here, like negative 5, or 5, negative 5, that would be false. Or this point here, which is 3, negative 4. So that would be false as well. All the falses down here, all the trues up there. So you can test just one of them and know where the rest of them are. We made it a dotted line because the points on the line will turn out to be false as well. Now, some of you might recognize when we go back to look right at the equation itself, y is greater than 2/3 x minus 5. We're saying the y values that are greater. That might have tipped off a number of you that we're looking for the greater values of y. So here's the y-axis, so that is above. Some of you can see that right away. Some people struggle with seeing that visually, and if that's you, you can use the test points to know where to shade. If you got the true point at 0, 0, good. You can go ahead and shade that whole region for the region of answers that will work. Let's look at a few more examples together. Okay, so let's look at number 2 on this page here. So they already put it in slope-intercept form for us, so that's nice. We can start by go ahead and putting negative 1, our y-intercept, and we'll go down 2 and to the right 1. So we can make a number of nice little points here. Continue adding points here on our graph. Now, we look at the symbol here. The symbol is telling us we need a solid line. if I picked a point right on here, like -1, 1, I would get a true statement. -1 for y less than or equal to -2 times 1. Sorry, -1 for x, +1 for y. Sorry about that. -1. So I'd get 1 is less than or equal to 2 times -1 is 2 minus 1. So 1 is less than or equal to 1. Well, that is a true statement. So the line is true. So because that line is true, we make it a solid line. Again, you'll have a ruler. Your line will be nice and crisp and straight. Okay, so we still want to know which side should we be shading on. Again, some of you will see the less than, and that'll be enough information to tell you which way to shade. But if we were to pick a test point like the test point 0, 0, okay, we plug 0 in. 0 for y less than or equal to 2 times 0 is 0. -1 is -1. So is 0 less than -1? No, that is false. 0 is not less than -1. So the origin here is a false point. Oh, well, do we have to keep guessing until we find a true point? No. As soon as we know that this half is false, we know that the other half is true. So we can go ahead and shade in this half. Just make sure it's clear where you've shaded, either lightly shaded with a pencil, or you can grab a highlighter if you really have that preference. Okay, let's look at an example like number 4. In number 4, notice the equation is written in standard form. So because it's in standard form, and I like how the coefficients are factors of the constant, we can go ahead and just graph by the intercepts. So I'm going to make 0 for x. Well, if that's 0, that's kind of gone. So I have -4 and 8. So divide both sides by -4, and I'd get -2. So that's our first intercept. And then if we put 0 in for y, well, 0 here, that's just going to give us that x is 8. So we have the point 8, 0, and 0, -2. So those are our 2 points. We see our symbol is just a less than, so we can go ahead and put a dotted line right through those. Again, you'll have a ruler. Make sure you put your arrows on the other ends. Okay, 0, 0 would be still a good test point. We'll test 0, 0. And if we put 0, 0 in here, we get 0 is less than 8. Is 0 less than 8? Sure it is. That's true. So we're going to shade towards 0. So, I'm sorry, cross my line a little bit. Let me do that a little bit better. 0 on this side. So that's the side that is true for our inequality here. All right, let's look at just a few more examples just to make sure we've covered every case here. Let's look at number 6. So number 6, I could actually do this by the intercepts. If I put 0 in for x, I'd get 0 for y. And if I put 0 in for y, I get 0 for x. The only problem is that both of my intercepts will turn out to be the same. You'll only get 1 point. You'll get the origin that this will pass through. So we're going to have to actually go ahead and find out what this is in slope-intercept form. So I'm going to subtract 3x from both sides. So 2y is less than -3x. Just that. There's no constant at the end. We'll divide both sides by 2. We don't flip the inequality because we're dividing by a positive number, but y is less than -3/2 x. So we start at the origin. We go down 3 and to the right 2, down 3 to the right 2, down 3 and to the right 2. And we've got some points there. We can go backwards the other way, up 3 over 2, up 3 over 2. 1, 2, 3. Make sure I'm not going cross-eyed. Up 3 and over 2. Okay, it is another strictly less than symbol, so we can make a dashed line that goes right through these points. Great. Oh, we have a problem now. We have been testing 0, 0 every time. Well, that's not going to work for us because our line goes right through 0, 0. So testing 0, 0 will not tell us which side we need to shade. So we can pick any point on either side. Might as well make your life as easy as possible. You could make it 1, 0, 0, 1, maybe even 1, 1. I'm going to go with 1, 1 just to test that as a point. So I'm testing 1, 1. So if I put that in, I'm going to get 3 times 1 plus 2 times 1. And is that less than 0? Well, is 5 less than 0? No, of course not. That is false. So we're going to go ahead and shade the other side. Awesome. We had a false point here at 1, 1, so we shaded the other side. Don't be thrown off when you get just one variable. As I said, it's usually got two variables in it, but if we've got an inequality with one variable, we can graph it on a coordinate plane still. If we had the equation y equals -4, that would be a horizontal line through -4. So we're going to still have a horizontal line through -4, but we're going to do more than just get the line for it. We're going to get a whole region of points for it. It's a solid line because of the less than or equal to. Now again, some of you might see y is less than or smaller than -4. That might tell you right away that's down below. But if you needed to, you could test 0, 0. If you put 0, 0 in, well, there's nowhere to plug the x in, so we just don't. We can plug the 0 in for y, so 0 is less than or equal to -4. Is that true? Nope, that is false. So because we got a false statement there, we are just shading down here on the bottom, below that line. And again, similarly, if we had an x equation, or an inequality here, x is greater than 7, okay, we'll go over to 7. It's going to be a vertical line, and it's going to be a dashed line through 7. Terrific. And we could again test 0, 0. And if we tested 0, 0, we can't plug anything in for y, but 0 in for x makes 0 greater than 7. Nope, that's false. So the origin is again false, so we shade the side that's away from that, which is over there. So we've looked at how to graph a linear inequality, how to show all of its lines. Remember that if it's a less than or equal to symbol, we're going to get a solid line, like in number 7 here. If it's just a less than or a greater than sign, we're going to get a dotted line. We can use 0, 0 as a test point unless the line is going through the origin, in which case we have to pick a different point as our test point. Thanks again for joining us, and we'll see you again next time.